Welcome to day 66, 7.4 surface area. So this is the second part of the arc length section, focusing on surface area today. So one thing, or before we get started, essentially what we're going to do, finding surface area, is we're going to revolve around a certain axis or a line, right? And so when we do, so if we take this line or this length here, and we rotate it around this axis, we form this solid, okay? But we just want the surface area, and so if we look at this solid, it looks like a cone with the top cut off, and that's called a frustum. So it's derived from the formula for the lateral surface area of a frustum, okay? And that formula, big S, is 2 pi RL. So R is really 1/2 the sum of these two radii here. So the big radii and the smaller radius, or sorry, the big radius and the smaller radius, add those together and we're just taking the average. L is that slant height, okay, and essentially it's arc length, right? So it's the length of that arc, which we know from the previous video is the square root of 1 plus f prime squared. Okay, so if we kind of go through and derive the formula for surface area, there's a couple diagrams to look at, and I'll be going back and forth to each of those. All right, so focusing over here on the left, by the intermediate value theorem, IVT, the average radius, okay, is really equal to f of some d value on this interval. Okay, so delta S, or that changing surface area, is 2 pi r average, or that f of di, times delta L, so that slant height, that change in the slant height. All right, so if we're kind of taking a look over on this diagram on the right, this is our delta L on some interval, and what's going to happen is this interval is going to become so tiny, and we're adding up all of these things as we're rotating it around. So going back over here, our average is really that f of di, and delta L, remember from yesterday's video, is really that distance formula, the square root of that delta x plus that delta y, or sorry, the square root of delta xi squared plus delta yi squared. We went through the derivation of this, and we get 2 pi times f of di times the square root of that arc length, or sorry, times the arc length. So 1 plus f prime of some c value squared delta x. So that's by our mean value theorem, which we walked through yesterday. So the surface area is really equal to the sum of all these small surface areas, these two-dimensional rotations here, okay, which is really equal to the limit as that partition goes to 0. So the amount of space between these values here goes so small, and the number of surface areas or pieces that we're adding goes to infinity. Okay, so that just leads us all the way to our actual surface area formula over here on the right hand side. Okay, so surface area is equal to 2 pi times the integral from a to b of f of x times the arc length, or the square root of 1 plus f prime of x squared. So we use this formula when we have a horizontal axis of revolution, all right, and we're rotating it around that way. Or in terms of y, the surface area is equal to 2 pi times the integral from c to d of f of y times the arc length in terms of y. And we would use that if we had a vertical axis of revolution. So now let's go ahead and jump into our first example. Okay, so we want to find the surface area when y equals 2 root x, and when that's revolved around the x-axis between the points 4, 4, and 9, 6. So I plotted the point 4, 4, I plotted the point 9, 6, so we're really looking at this curve here. I want the surface area of this portion when it's rotated around our x-axis. So if you kind of look at it, that's this yellow highlighted piece. That's the part of the frustum that we're looking at. Our radius is going to be in terms of x because the height of that is our y. right? Wherever I am, that distance is the y distance, okay? So that kind of leads us over here to the right-hand side, where y is going to be the radius in terms of x, which we already have 2 root x. So that's no big deal. But we will also need y prime, all right, and y prime squared. So you can do this all in the original formula, or you can do it ahead of time. Sometimes I like to do it ahead of time. It makes things a little cleaner when I then jump to the surface area formulas. So we get y prime to be 1 over x to the 1/2. So y prime squared is going to be 1 over x. So now what did we do? We just jump into our surface area formula. And as we work through it, we'll get to our final answer here. So again, we're just substituting. So 2 pi times the integral from 4 to 9, because those are the x values, of f of x, that's 2 root x, and then our arc length, the square root of 1 plus 1 over x. So kind of cleaning this portion up, that gets me x plus 1 over x. That 2 out front is where we get the 4 pi. If we combine the radicals, we have the square root of x times x plus 1 over x, so the x's will cancel, and we're really just left up with this cleaned up integral of 4 pi times the integral 4 to 9 of the square root of x plus 1. We'll need our u substitution. So as we go through, I kind of skipped a couple points here, and I substituted back right away, and then we evaluate. So here is our approximate if we throw it into the calculator. Don't forget, we round to 3 decimals, or we just cut it off after the 3rd decimal place. This last example, I want you to try on your own. It says to determine the arc length, so we're going back to what we talked about in yesterday's video. From 0 to 1 to 2 root 3 comma 4, for 9x squared equals 4 times the quantity y minus 1 cubed. So remember from yesterday, here's our arc length formula. All right, remember arc length is the little s. So we really just want the length of this piece of our curve. Okay, so I'm going to let you kind of do some of the back work, and I will kind of lead you through piece by piece until the end. So go ahead, give it a try your setup, all right, and check back when you can. So the first thing I did was I looked at our equation, 9x squared equals 4 times the quantity y minus 1 cubed, and I thought it was going to be easier to solve for x, okay? So divided by 9, took the square root of both sides. When you take the square root, we do get that plus or minus. But we're just strictly looking on the interval from 0 to 2 root 3 for our x values. So we're going to focus on the positive version of x here. All right, so our x is really equal to 2/3 times y minus 1 to the 3/2 on our interval. Okay, so in order to find the arc length, we need the derivative of x. And when we find the derivative of x, we get y minus 1 to the 1/2. And then right away, I kind of clean things up. So squaring our derivative, we'll get y minus 1. And then we have to add 1 to that because that's what our formula for arc length is. So like I said, I just did all of the stuff that's underneath that radical. I did that all up front. So now when we go ahead and find the arc length, it's going to be nice and easy to do. So the arc length is equal to the integral from 1 to 4 of the square root of y. It goes from 1 to 4 because that's our y values on that interval. All right, and you guys know how to go ahead and take that integral, evaluate it, and in the end we get 14/3. If you have questions on this, let me know.